Welcome to Learning with Philemon. In this video, we will be looking at chemical equations and how to balance them. A chemical equation uses chemical formula to show what happens in a chemical reaction. The chemicals you start off with are on the left and are called reactants. The chemicals that are produced are on the right and are called the products. There is a common misconception that the arrow in between means equals. This is not the case. The arrow means yields or produces, in other words. The reactants react to produce the products. In the equation, you will find chemical species, elements, molecules, or compounds, all represented using the chemical symbols of the elements. To review the difference between these terms, have a look at the video Elements, Compounds, and Mixtures. Sometimes you will see a number in front of one of the chemicals. This number is called a coefficient and tells us the number of the particular reactant or product involved in the reaction. In this case, there are two hydrogen chloride HCl molecules involved in the reaction. Note that in each hydrogen chloride molecule, there is a hydrogen atom bonded to a chlorine atom. The small number to the right of a chemical symbol is called a subscript. This tells us how many atoms of an element are in a molecule or compound. In this case, the 2 means that there are 2 hydrogen atoms per hydrogen molecule, H2. The 2 hydrogen atoms are bonded together. If there is no subscript, that means there is only one atom of that element. In magnesium chloride, for example, MgCl2, there is 1 magnesium and 2 chlorine atoms. Note that the subscript 2 only applies to chlorine. According to the law of conservation of mass, atoms can neither be created nor destroyed. Therefore, in a chemical reaction, you must have the same number of atoms on the reactant and the product side. Using the diagrams as an aid, we can see that on both sides we have 1 magnesium atom, 2 hydrogen atoms, and 2 chlorine atoms. From the reactant to the product side, the number or types of atoms has not changed. The only thing that has changed is the arrangement of atoms. For example, the chlorine atoms were bonded to hydrogen atoms in the reactant side and are then bonded to a magnesium atom in the product side. This is why chemical reactions are defined as a rearrangement of atoms. Note that the atoms in this diagram are not to scale, and the bonding in magnesium chloride is not accurately depicted. You will often be asked to balance chemical equations. In this type of question, you are given a chemical equation, but need to add coefficients so that the number of atoms is equal on both sides. You can start by counting the number of atoms of each element on each side. We have 1 carbon atom, 4 hydrogen atoms, and 2 oxygen atoms on the reactant side. We have 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms, 2 from here and 1 from here, on the product side. At this point, the equation is not balanced as we do not have an equal number of hydrogen and oxygen atoms. Adding a coefficient of 2 in front of water, H2O, means that we have 2 H2O molecules. Therefore, now we have 4 hydrogen atoms. We also now have 4 oxygen atoms, 2 from the water molecules and 2 from the carbon dioxide molecule, CO2. You will not always have diagrams drawn for you, so you also need to think about it mathematically. To find the number of atoms, you can multiply the coefficient by the subscript of each element. 2 times 2 gives 4 hydrogen atoms. 2 times 1 gives 2 oxygen atoms. Next, we need to balance the number of oxygen atoms. Adding a 2 in front of oxygen, O2, gives us 4 oxygen atoms on the reactant side. Now we have the same number of carbon, hydrogen, and oxygen atoms on both sides of the equation. The chemical equation is balanced. Now let's have a look at a slightly more complicated example without diagrams to help us. The number of atoms of each element on each side is written. Whenever you have parentheses around part of a chemical formula, the subscript applies to all the elements within the parentheses. We have 2 times 1 nitrogen atoms, 2 nitrogen atoms, and 3 times 2, 6 oxygen atoms on the right-hand side. Note that the subscript does not apply to calcium, Ca, so you only have 1. To balance this equation, we can add a 2 in front of silver nitrate, AgNO3. Multiplying the subscripts by the coefficient, we now have 2 silver Ag atoms, 2 nitrogen N atoms, and 6 oxygen O atoms. We then add a 2 in front of silver bromide, AgBr. We now have 2 silver atoms and 2 bromine Br atoms. The calcium atoms are already balanced. To consolidate your learning, try to balance the equations in the description. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.